Hey, good morning, guys. I want to talk to you guys today about radical functions and transformations. So we talked about some other types of functions and the transformations and translations that can happen. And we did, right? We talked about, oops, we talked about linear, right? And how essentially all we can do is move it up and down, right? We did that by changing the b value. The b value changed up and down, and the m value is the slope. So this was how steep it was. This is the y-intercept, right? Then we talked about quadratic, right? We said, and that was, we talked about that fairly recently, right? That was f of x, right? And it was ax minus h squared plus k, right? And that was also very similar when we did absolute value. Right? Same thing, ax minus h plus k, right? So we looked at some of these things and what happened to the graphs and how they changed. Okay, so today we're talking about the same thing, except we're going to talk about radicals. Okay, more specifically, we're going to be talking about square root functions. Okay, so if you have questions about cube root functions or fourth root functions, sorry, not for today. Radical functions aren't going to be quite as nice and clean as these. So today I just want to go over kind of what's going to change the shape of the graph and how it's going to change the shape of the graph. Okay, so oops, not that one. Let's start by taking a look at the parent function. So we're on Desmos. Okay, so the parent function is y is equal to square root. Oops, just QRT of x. Okay, so that is our parent function. That is the most basic function. That is the most basic function. Okay, there's nothing to it that is as basic as it gets. Hold on, I just want to make the grid lines a little bit different. Okay. All right, now let's talk about what we can do and what's important. Okay. Now for these two, for quadratics and absolute value, we're looking for the vertex, right? Negative hk was the location of the vertex. It was just a matter of whether it was kind of a U shape or whether it was kind of a V shape. We were looking for the vertex, right? In this case, we're not going to be looking for the vertex. We're going to be looking for the endpoint, okay? And if we think about it, the kind of limiting factor of a square root function is not the same thing. What limits a square root factor is the fact that anything in here can't be negative, right? So anything that comes out of the square root sign has to be, I can't even call it x, okay? Anything that has to be greater than or equal to 0, right? Anything that comes out of here, right? Anything that goes in here has to be 0. So let me give you an example. So if I said, what's the square root of x? Well, what's the smallest number x can be? X has to be 0, right? Or anything bigger than 0. X could be 1. X could be 2, all right? Any decimal in between there. X, whatever comes out of here has to be good, has to be 0 or bigger, right? What if I said this? Right? Now let's think about this for a second. In this case, x had to be greater than or equal to 0. Well, in this case, actually, there's a smaller number we can put in. So the smallest number I can put in here is negative 10, right? Because what if I said negative 10 plus 10? Well, negative 10 plus 10 is 0, and that's what we get, right? That's the smallest number I can put in here, negative 10, because that's the smallest number I can take a square root of is 0. If I were to put in negative 11, well, negative 11 plus 10 is negative 1. That's no good. I can't take the square root of negative 1, right? So again, we have to think about what makes the inside of our square root equal to 0, and that's going to be a big part about what we do. So in this case, we will say x has to be greater than or equal to negative 10. So essentially what you want to do is anything that's inside here, set it equal to negative 10. Let's go back and see what that graph looks like. Y is equal to the square root of x plus 10. And if you noticed, it shifted over 10 spots, right? It shifted over to negative 10, right? And I know what you're thinking is, hey, that's what we expected, right? Typically, for all of our other functions, right, it was always negative h. It's always the reverse of what was inside the parentheses. And in fact, if we look at these, it puts anything that's underneath the square root is automatically in parentheses. But it's not quite that simple for this. It's not quite, because sometimes you might have a number out in front here. So let's talk about that. So I said, hey, what's the square root of 2x plus 5? Well, you might be saying, hey, let's just move it over the 5, right? But it's not quite that simple. If I want to know what the smallest number I can put in here is, what I need to do, again, is take what's on the inside and set it equal to 0. 0 is the smallest number it's allowed to be. So again, what am I going to do? Classic kind of basic algebra is a linear equation. Subtract 5 from both sides. Divide by 2 on both sides. And I'll find out that x can be, well, negative 5 divided by 2 is going to be negative 2.5. So the smallest number this one's going to be allowed to be is negative 2.5. So let's graph it. Let's take a look. Okay, and if you notice, there it is right there. Okay, so again, it's not quite as simple as the other ones, but let's take a look at some other things. Okay, so again, what's going to be the limiting factor? What makes it equal to 0? Okay, let's take our basic square root function and see what happens when we start messing with it a little bit. Okay, so anything on the inside is going to shift it around. Now, if there's nothing multiplied, we still get that negative h plus k rule, right? But again, when I start multiplying, okay, so anything that's on the inside, you need to multiply by, to set equal to 0 to find out what the smallest number x can be. Okay. Y on the other hand, again, if I add 7 on the outside, I get 7 on the outside, and that really doesn't matter about kind of what I multiply these by to get, right? So we said that inside here we'll change the left and right. Outside here, though, it still starts at 7. So that same rule that we had for the other functions is still going to be true here, right? The difference is where is it going to start? What x value is it going to start at, okay? If we start throwing in negative numbers, well, if I throw a negative on the inside, it flips this way, okay? Why does it flip that way? Well, again, if we think about it, if I said y is equal to the square root of negative x, before I can only put in positive numbers. Now, believe it or not, again, I can only put in negative numbers, right? Because, again, I can only take the square root of a positive number. So if I get the square root of a negative number, that's no good. But here, what if I put in negative 9? Well, it's the square root of negative 9. Well, all of a sudden, that negative in there makes all the negative numbers that I put in, okay, I have a double negative, that makes it positive, right? So now my positive numbers are no good, because now if I put in, I don't know, 16, y is equal to the square root of negative 16. Well, I can't take the square root of negative 16. So all of a sudden, the tables are turned. What was okay, positive numbers, is now not okay. What was not okay, negative numbers, is now totally fine. So what you'll see, essentially, is that if you have a negative on the inside, it's going to flip your graph over the y-axis, okay? If you have a negative number on the outside, it's going to flip your number over the x-axis. If you have a negative on the inside and a negative on the outside, it's going to flip things over this way, okay? So listen, a lot of this is really Algebra 2 stuff. I just want to give you guys a quick overview of what it's going to look like when we start doing these. So what we'll look at tomorrow is essentially how to find the domain and range from an equation. But I just wanted you guys to see visually kind of why some of these things are going to happen. So hope this didn't confuse you guys too much. Hopefully tomorrow's video might clear it up even a little bit more for you guys. Thanks.